Hello, good evening, guys. This is Monish, third year AMLB from Anurag University. Today we are going to see a KNN classification. We are going to use the same data set as we have used in the previous video. If you haven't seen it, I would recommend you to go and look at it. We have done logistic regression the previous time, but now we are going to see the KNN classification model now. Okay, so to work with the KNN model, first I'm going to import few libraries which are required to do this. I'm going to import pandas for working with the data frames, NumPy for doing few numerical operations, Seaborn for visualizing data, and from sklearn model underscore select I'm going to import train test and split module. I'm going to explain about it in the coming steps. Next, from sklearn.neighbors have import kneighbors classifier. This is the classifier which we are going to use for the classification today. Next, from sklearn.metrics I have imported accuracy score and confusion matrix. These are nothing but few performance metrics which we are going to use to test the accuracy of a model, and also to see that how many values we have predicted correctly and how many values we have predicted wrongly. Okay, so I'm going to run this. Next, I'm going to read the CSV file where all the data is stored. I've stored it with the name income.csv. Basically today we are going to we have a data set from which we are going to try to classify the individuals if they have a salary greater than 50k or else less than 50k. So I'm going to read the CSV file now. After reading this, I'm going to create a copy. Basically, while doing real-time projects, you don't usually work with the original data. Instead, you try to create a copy and try to work on that. So I'm going to create a copy right now. After creating the copy, I'm going to check out exactly what we are working with. By this I mean that what are all the columns present in the data frame. We're also going to see the data types of each column, if it's relevant or not. For example, age should always be a number. It shouldn't be an object type. So similarly, we'll be checking for each column if the data type matches it or not. Okay, over here all the columns match with the data types. So next, what we are going to do is we are going to check if there are any null spaces present in the data set. If you use isNull function, the entire data frame is going to be printed with boolean values, either true or false. So you can't really say anything using this information, right? So what we are going to do is we are going to use .sum function. We are going to place .sum at the end of this function so that we'll get exact number of null values present in the data frame. As you can see over here, there are no null values present right now. Well, that's good, so we can go ahead with the rest of our operations. Next, I'm going to do data.describe. Basically, we'll be getting the count, mean, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, and the max value of particular columns. So here the age column has a total count of 31,978. This means that there are 31,978 columns present in the age column. The mean of this column is 38.5. The standard deviation is 13.6. The minimum value in this column is 17 and the maximum value is 19. The median value is 37. Similarly, you can see for the capital gain. The capital gain is nothing but If people are trying to invest their money in a particular field, the amount of profit you gain is nothing but the capital gain. Since many people don't usually tend to invest their money, here you can see that the minimum amount is 0 and the maximum amount is 99,999. This capital gain column also has 31,978 rows. The mean of this column is 1064. The standard deviation is 7298. Similarly, this capital loss is nothing but when you invest and you get a loss after investing. This loss amount is nothing but your capital loss. Next, looking at hours per week. This column contains the number of hours individual works per week, then frequency or the count of the total number of rows present in this column is 31,978. The mean value is 40. The standard deviation is 12.3. The minimum value is 1. The median value is 40 and the maximum value is 99. Next, we are going to use the same function .describe, but we are going to mention a new parameter over here, include equal to O. By doing this, we'll be getting 4 unique features of the columns over here, namely the count, unique, top and frequency. In the column job type, the number of rows are 31,978. There are 9 unique values in the column job type, and the highest frequency value is private with the frequency 22,286. You can see similarly for the rest of the columns over here. So going to the next step, basically I have done dot value counts over here, so that we'll be getting unique values and the frequency from each column. I've chosen specifically these 2 columns because in the entire data frame, as we can see over here, I have done it for each and every column, but only these 2 specific columns have a special symbol, namely the question mark over here. So we'll be trying to remove this question marks and replace those with null values. So next, I'm going to print the unique values present in 2 columns, job type and occupation. I'm doing this so that I can see how exactly this question mark is present in the data frame. As you can see over here, the question mark has a leading space in front of it. So while giving a new command, we need to keep in mind that the question mark has a leading space in front of it, and we need to mention it as the same. In the next command, I try to read the CSV file again, but I have given a new parameter over here, namely na_values equal to question mark. So what basically this does means it converts all the question mark characters into null values. So after we run this, we are going to see the number of null values present in the data frame in each column. So just a second, let me print this. Okay, as you can see over here, there are 1809 null values in job type and there are 1816 null values in occupation. So all the special characters, which is nothing but the question mark, has been replaced with null values. So now I'm going to drop all these null values by using the drop na function. So after doing this, when we try to print the null values again, okay, give me a second. We have used data 2. We have stored the data frame, newly updated data frame in data2. So I'm going to print data2. As you can see over here, all the null values has been dropped and there are no more null values in the data frame. So next I'm going to use the map function to convert all the values named less than or equal to 50k and the greater than 50k into zeros and ones respectively. So basically we are doing this because we are trying to feed the model with our data. So the data usually takes numerical values, so we're trying to convert all the strings into numerical values. So in the salary status column we are trying to convert all the strings named less than or equal to 50k to 0 and greater than 50k to 1. So after doing this, you can see that all the values have been converted into zeros and ones. Next I'm going to use the getDummies function to convert. Basically what getDummies does is it converts each and every column into numerical type. How this is done means, for example, okay, let's take the example of job type. As you can see over here, in the unique values present in the job type column, in one job type column there are these many unique values. So what getDummies does exactly means, it converts the single column job type into several columns, namely federal government, local government, never worked, private, self-employment inc, etc. So the getDummies converts one column into multiple columns and gives the values as zeros and ones. So here when you try to print out the new set of columns after using the getDummies function, you will see that the number of columns has grown exponentially. This is basically because the getDummies converts every column into all its values, like every single unique value, and gives it either zeros or ones. For example, let's take the occupation tab. So if your occupation is something like farm fishing, so this particular farm fishing column will be given the value 1 and the other occupation columns will be given the value 0. So if you are present in the farm fishing occupation, then the column having farming fishing will be 1. The value of the column farming fishing will be 1 and the other columns having occupation will be 0. Next we are going to create features. Basically we are trying to separate the independent variables and the dependent variables so that we can train our model. Here the dependent variable is nothing but the salary status, because we are trying to classify the individuals into greater than 50k or else less than or equal to 50k. So the dependent variable over here is salary status. So we are trying to remove the salary status column from the entire list of columns. Now we are trying to create a dependent variable. So usually in data science we try to assign the dependent variable to y and all the independent variables to x. So I'm going to do this right now. So after doing this, we have separated the dependent and independent variables. I'm going to use the train test split function to basically separate the training and the testing data sets. For training the model, we'll be using the training data set, and for testing the model, for testing the model's accuracy, we'll be using the testing data set. So what I've done is I've given the parameters x, y. These are nothing but the dependent and independent variables, and I've kept the parameter test size value as 0.3. What this thus means, it gives 30% of the data to the testing data set, and it gives the remaining 70% to the training data set. And I have given random state equal to 0 because every time we run this command, we don't want new set of values, but we want the same set of values. So I have given a random state as 0. I'm going to run this now. Next, we are trying to create a k neighbors classifier variable. I've given the n neighbors value as 5 for now. So after creating this, I'm fitting the training data to this model, and now I'm trying to test this model using the testing data set. And after doing this, I'm creating a confusion matrix which will allow us to see how many correctly predicted outputs and wrongly predicted outcomes. If you see the diagonal values over here, those are the number of correctly predicted outputs, and the values which are not on the diagonal are the wrongly predicted values. So I'm going to check the accuracy score now. For this, I'm going to use the testing data set as well as the prediction which we have just made. So as you can see, the model has 83% accuracy. Next, I'm going to just print the total number of misclassified samples. You can also get this misclassified samples by adding the non-diagonal elements in our confusion matrix. So basically we have predicted 1493 elements wrong. Next, basically have taken here n neighbors value as 5. So if you don't know how exactly you should take the value of the n neighbors, one of the methods you can go for is you can calculate the error for the values of k ranging between 1 and 20. By this you will be getting the number of error values for each value of k, so that you can go ahead with using that particular value of k. What this k value does means, it basically creates groups. So if you have given the number k as 5, it creates 5 groups in the entire data set, and it uses these groups for classifying. So I'm going to right now check for which value of k we'll be getting the least number of error values. In this for loop, I have just repeated all these steps which we have done over here, 1, 2, 3 over here, so that we'll be getting a list of number of error values for each value of k ranging between 1 and 20. Okay, so here you can see that for the value k equal to 16, we have got the least number of errors. So you can go ahead with taking the value of k so that the accuracy of your model increases. So that's it from this video, guys. Video we have seen how to use KNN for doing a simple classification test study where we have classified the individuals based on their salary greater than or equal to 50k or less than 50k. Thank you for watching. Goodbye.